Okay, let's continue. Now we will go into two experiments. The first one is the EVP experiment, and another one will be the IPv6 routing experiment. And for the two experiment, I think it is not so difficult, and the experiment itself is not be designed too difficult. So I will not give you a demonstrate about the two experiment, but for some experiment, I think it will be a little difficulties, and maybe the technology will not be so familiar for you guys. For example, for the VXLAN experiment, and for the utilize the campus network and the SD1, SR, SPLS, SV6, and the last three part, it will be the wait a moment, it will be three experiment about the network automation and development. Uh, and I think for this experiment, it is necessary for you guys to give you a demonstrate. So today, the EVP experiment and IPv6 routing technology experiment will still just we see what we will do in the experiment, and you will find that it is not so difficult. And one thing I need to emphasize here is we have two places in the lab guide. Will have the situation with the EVPN technologies. The first one is the EVPN itself, but you will find that it is just a simple experiment, just because it is another version of the MPLS VPN. Just we change the control plan from the BGP VPN v4 to EVPN. Just we change the address families, and this experiment, its aim is to show you what EVPN can do. You will find that we can use EVPN to carry the just the traditional routers, and all the things that VPN v4 can do, the EVPN can do it. But you will find that, but it is not the most common use in our experiment. So in another lab guide experiment, it is the distributed VXLAN gateway. We will also use the EVPN. You will find that we will create the EVPN instance, and we will establish BGP EVPN peer, and we will see what is the BGP EVPN routing looks like, and so now for today we will just have a brief look at the EVPN. This experiment is just because it is another version of the MPLS VPN. It is we just change the protocol that transmit VPN v4 router. No, we don't have VPN v4 routers. We only have the EVPN routers. And okay, now first let's look at the EVPN protocols. And I think you still have the memories about what we do in the MPLS VPN. Yes, we use 6 routers, and all the routers are the NE device, just because not every AR routers can support EVPN. You will find that for this experiment, all the routers are NE, not the AR routers. And other things is similar with the MPLS VPN, the same topologies, the same configurations, and the same RT values. So just look at again what we do in the experiment. In this experiment, we use 3 NE routers to function as backbone routers, and we use 3 routers to function as CE routers, and we exchange routers between CE and PEs, and then we use the BGP EVPN address family to exchange routers, and it is not VPN v4 routers, it is EVPN routers, and then we designed the RT routers on the HQ's PE, so that all the routers will exchanged from the CE and PEs, and then let all the routers that send to PEs, I mean the branches PEs, and the next hop will be set to our device. And now let's look at what we do in the experiment. The first thing is we will configure the basic IP address of all the devices. You shall know that, and then we configure SIS, and we configure the AI, the MPLS in the AS in the backbone areas. And then what is different? The different things is when we create the VP instance, it will be a little different, and the method of between the BGP peer will be a little different. So just let's look at what is different when we use EVPN, this protocol, to function as the control plane of the MPLS VPN. Okay, the first part is the basic device configuration. It is very easy, and we can just skip them. And then it is configure SIS, and it is also very easy. We just configure the SIS net ID and enable SIS process in all interconnected interface. And then it is MPLS, it is still the same. We need to configure the MPLS RSID and enable MPLS and MPLS LDP function globally. And then we need to enable these two features on interconnected interface. So let's look at what is different. The first thing is we shall know that we use the EVPN protocols to deliver the router that learn from the CE. So the address family, you will find that it is not the VPN v4, it is EVPN. And but for other things, you will find that the command is the same. For example, how to enable the BGP peer, and we still need to disable policy. Wait a moment, what is different? To configure the IP LDP on R. Yes, we need to do. Just because you find that, just because you just think about it, RR still needs to function as forwarder, right? If yes, and in our design, RR will be the next hop. RR will be next hop. RR be next hop. So you need to enable the MPLS LDP. And you will find that the address family is different, but the config is still the same. We need to disable policy VPN target check to let the RR can receive the router that from the branch, right? And now let's look at what is the different things. The first different things is we have mentioned in the next experiment in the MPLS VPN, we see that we will use two interfaces. One is the physical interface, and another is the logical interface. It is a sub interface. We will establish two BGP peer between the HQ's CE and PE, just to use one peer is used to send a router, and another BGP peer is used to receive a router. So let's look at what is different. Okay, now let's look at the first things you will find that when we try to configure the IP VP instance or the VRF, you will find that all for the RT value, for the RT value, we need to followed by this parameter EVPN. So it is used what it means. You in the traditional MPLS VPN, we know that we only need to configure the RT value, right, without the EVPN. So it means this RT value is used for the VPN v4 routers. But now we don't have the VPN v4 routers. the root is the EVPN routers. If you don't use these parameters, this RT value will not work for EVPN routers. It means maybe you will send the EVPN routers to your peer, but the router will not carry any RT values. So maybe I can show you that I can use one device display IPv6 instance. Oh, you will find that IPv6 instance VPN. Now you can find that in this VPN instance, IPv6 instance we configured the RT values followed by the EVPN parameter. It means this RT value will be carried by EVPN routers. But now maybe you will have the questions if this VPN instance can used for maybe a VPN v4 address families. Yes, it can be, just because maybe you can find that I use this command VPN target without the EVPN parameters. You will find that now we have two RT values inside this VPN instance. This one, without the EVPN parameters, it will be carried by VPN v4 routers. And this RT value, followed by a EVPN parameter, it will be carried in the EVPN routers. It means this VPN instance, you can bundle it for different, maybe different CEs. And maybe one CE is route is carried by VPN v4, and another CE, it is the route will be carried by the EVPN router. So that is the different. Okay, that is the first different, and another one is what is the European level 2? Yes, you have questions about European level 2. In Huawei device, if you want to configure RT value for the European level 2, I can show you how to configure it. But about this these features, we will talk it about in the VXLAN distributed gateway. But now I can show you how to configure it. Wait a moment, I can show you how to configure it. It should be like this. EVPN. You can find that it is Huawei device, and we use this command. We use this command to create a VPN instance for the layer 2, European layer 2. And you should notice that this is a Huawei switches. So this router will be the European type 2 router, is right? It is. And if we find that in this VPN instance, you can configure the VPN target. It is the EVPN VPN instance, and it has its RD values and it has its RT values. It is not. It is different from the IPv6 instance, and you will find that in this device, it has the EVPN VPN instance and IPv6 instance in the same time, but they are binding to different places. Yes, yes. Just because this, you should know that we have this command inside it before it. It is a EVPN VPN instance. It is not a traditional IPv6 instance. And you will find that for this VPN instance, EVPN 5, it is used. Wait a moment, I need to check it where it is banned for. Which place it is coming. Okay, now you can find that this is a VPN instance, and you can find that before VPN instance its parameter is IP, right? And you can find that inside it we configure the RT values and followed by EVPN parameters. And this VPN instance, it before it has a parameter, its name is EVPN. It means that this VPN instance is used for EVPN level 2. And you can find that, wait a moment, it should be bound to the BD. Okay, you can find that this is a BD I think you should know what is it. It is BD. It means broadcast domain in the VXLAN. I mean, this is for the VXLAN scenarios. So I don't know if you are talking about this scenarios. You should know that EVPN level 2 can use the full VXLAN or for the just the traditional level 2 VPN, right? And if you are talking about the EVPN level 2 EVPN level 2 VPN, it is different, and you can find that this command is different, but it is still use this command bridge domain, and still use this command to bind the EVPN VPN instance. Maybe we can check that if this command is the same, we can configure the bridge domain. Yes, we can configure the bridge domain. And yes, I think it is the same, but the mode is you can find that BD domain. In the routers, I think the command is the same. If you want to transmission with VPN command for VPN number 2. Can I configure traditional VPN instance with EVPN command in RT command for VPN level 2? A good question. I will check it just because I didn't configure it for the EVPN level 2 VPN. Wait a moment. I think maybe we can find the answer in the slide. Just because I have a brief look about the European slide. I think it has configure example for it, so I can let's check it. Okay, I think it has config. Example. Wait a moment. Wait a moment. What is VPN fundamentals? European bridge domains. You mean European level 2? I need to actually check it. European level 2. European. Windows bridge domain. EVPN convince me to carry level 3 to service. Wait a moment, I need to check it. If it has to carry level 2. For convention check. Oh, wait a moment. I think if we see this slide, we find that if we want to use VPN to carry level 2 service, and I think you can find that it is still use this. It is still use this. And let's check it on the Huawei's official website. Config VPN, EVPN, level 2 VPN, VPS, VPN. EVPN level 2 over S value over SLv6. Level 2 eLearning access examples. Level 2 VPN, VPS, DCI, VPS, VPWS, EVPN, VP instance, VP instance. So maybe I think the answer is no, but I will check it for you, and maybe I will tell the next teacher tomorrow and to tell your answer. But now, from my opinion, if you want to use VPN to carry the level 2 service, you need to use you should use the VPN instance, not the traditional VPN instance with VPN command. Okay. Okay, now let's look at another command that we used. And another command is this command. You should know that for the EVPN routers, you should know that for the EVPN routers, you should know that for the EVPN routers, it is different from the traditional routers, and it is also it is different from the VPN-V4 routers. So now what we do is we need to use the EVPN router and then to let the EVPN routers can be forwarded by the MPLS network. So we need to use this command EVPN MPLS routing enables. So we will advertise IP prefix routers by EVPN. So it means that without this command, maybe you have already learned a router from the CE, but the router will not be transmit to a EVPN router, right? So this command is also, maybe you will find that in other experiment, if we use EVPN, you will find that we will use this command just to let for the VPN instance, it can receive and generate the router just from the EVPN routers, or just let the normal routers to become EVPN router. And for another configuration, other configuration is the same. It is we need to bind the VPN instance to a level 3 interface, and then we need to enable the peer relationship inside the VPN instance address family. And okay, that is the same, and other things is same. And for the branch 2 and branch 1, the configuration is the same. And for all the branches and HQ, we need to design the RT values as we designed. And just let's look at the last different if we use the EVPN protocols. The first one is this. If we want, if we want these routers, if we want the routers that can be, you know that we will establish a router for this device for the P2 and P4, they exchange routers from CE by use the BGP protocols, and we shall know that it will receive the router inside the BGP VPN instance, right? So we need to enable peer relationship inside BGP VPN instance will. But we need to use another additional command. It is this command. It should be it is this command. Advantage level 2 VPN EVPN. What it means? It means by use this command, the PE2 and the PE4 will send the router to its CE, and the router received from CE will be sent to another EVPN peers. So you will find that if we use the EVPN protocols, we have some point need to be noticed. And then is the check the router on all the device, on the CE device and PE device. First, let's check on the PE device. You will find that the command is a little different. We use this command, display BGP, EVPN, or routing tables to check the EVPN routers. And you will find that for EVPN routers, it is different from VPN V4 routers. You can find that this is a EVPN&IPv6 routers. It means it is a type 5 routers. And in this routers, you can find the router itself, the router prefix, and the mask, the prefix length. All these things will be carried by the EVPN routers. And you can still find, you can still use this command to check VPN V4 routers just because we use a command. Traditional, can I configure traditional VPN level 2? You can, okay. For VPN level 2s, John, I think you can maybe you can send example configuration link of our official user list. And then looks like just because we use this command, I don't know if you have remember it. Just in this place, we use this command UAP MPLS alternatives enable, so the EVPN routers will be converted to MPLS routing VPN V4 routers. So you can still use this command to check the VPN V4 routers. You can find that it still has the VPN V4 routers, but you should know that it is not delivered by the VPN V4 address families. It is converted from the EVPN address family. Okay, and that is different from this experiment EVPN with this experiment MPLS VPN. They have the same topologies, they have the same aims, but the only different things is we change the control plan from the VPN V4 to EVPNs. And for this experiment, its aim is to show you what the EVPN can be used for and what is the capabilities of EVPN. That is its aim. Okay, if you have any questions or you don't know what this experiment is talking about, maybe you can after our training, maybe you can see the record of these trainings. You can find it in this experiment. They are the same experiment with the same aim. Okay, then let's go to the second experiment. It is the IPv4 routing technologies. You will find that this experiment is also not a difficulty experiment, just because in this experiment, you will find that maybe the topology is just, you will find that you will feel be similar to this topology. And the interconnection address is really designed just because the address family. Now it is IPv6. And what we need to do is we need to use the IPv4 routing protocols, maybe the IGP or the EGP or the BGP to finish finishes the connection between every device. So you will find that in this topology we will use the IPv4 static routers. We will use the BGP, MPBGP address families that used for IPv6, and we will use IPv6 SS and the OSPF v3. But you will find that we don't use so many advanced features, just to show you how to configure the IGP protocols and the BGP protocols in the IPv6 version. So let's look at what we need to do in this experiment. The first thing is configure the interconnection IP address of the device. And then we need to deploy OSPF v3. You will find that in this topology, between PE2 and PE1, we run the OSPF v3. And between PE3 and PE4, we run the OSPF v3. And then in next step, we need to deploy SIS, but it is for IPv6 topology. And I think for SIS, it is the simplest protocol if you want to use its IPv6 version, just because we needed another traditional additional command can let can let SIS protocol to support IPv6. And you can find that in this topologies, in between P2, P4, and P2, we use the IPv6 SIS. And then it is we need to do route import between the SIS and OSPF process. It means on the P2 and P4, we need to import router from OSPF v3 to SIS and import SIS router to OSPF v3. And then is we need to establish IBGP peer relationship between P2 and P4. And then in the next step, we need to establish a BGP peer relationship between P1 and P2. And we don't use the direct connected interface. We use the loopback 0 interface. Use this interface as a source address. So you should know that for the eBGP peer, we need to configure. We need to create. We need to use the IPv6 static route to let the PE1, the P1's loopback zeros and P2's loopback zeros, they can reach each other. And the last thing is if we want the PE1 and PE3 can communication with P1's loopback zeros interface, we need to do route import. It is import the BGP routers to SIS. So PE1 and PE3 can render the route that generated by P1 by using the IGP protocol. Just because you can find that if we check the sequence of this experiment, you will find that IPv6 is before MPLS VPNs. So in this experiment, we can't use MPLS VPN just because maybe the student they don't know how to deploy MPLS VPN. The right answer for this topology is we should to deploy the MPLS VPN, right? But now, just because maybe the student don't know how to deploy MPLS VPN, so we use maybe you can say it is a wrong way to achieve our requirement to let PE1 and PE3 can communication with P1's loopback 0. Okay, now let's look at what we do in our experiment. The first one is configure the IP address and another basic configure. It includes configure the. You should notice that all the device is the NE device. So for NE device, it is not AI routers. It is NE device. It is NE device. It is a net engine device. For these routers, the command will not be will not be taken effect if you use it. For example, if I change the system to P1, you will find that the command is not take effect just because you need to use this command commit to let the command that you input to take effect, and then you will find that this command now it take effect, but it will be useful for the real network. But now we are just in the experiment, so we can use this command. System will immediately. It means all the command will take effect as soon as possible, just like the AI device. So you can find that we need to change it back to P1. It will take effect when you type it and enter it. Okay, and next is configure the IPv6 address for the interconnection interface and loopback 0 interface on this device. And for all the devices, the basic command is the same. Configure the interconnection interface's IPv6 address and configure the loopback 0 interface. Now let's look at after we finish the basic config, what we will do. The first is we need to check the connectivity activities between those devices. So we use this command ping IPv6. It is not the normal ping, it is a ping IPv6 to do a web IPv6 ping. And then now we need to deploy OSPF v3. And we need to deploy OSPF v3 between PE1 and PE2 and between PE3 and PE4. We need to set the OSPF process to its process ID to 1. What is device site for training since it is no longer available? Maybe I think you need to use the real device. What is the advice for the lab setup for training? And I don't know what the next version about the ESP will be released, but before the next version of the ESP be released, maybe you need to use your device. No other solutions for the EVPN lab setup. No. But I can what things I can tell you is for the S device. I mean, for example, you can find that for the SCR switch, what should be this device? For example, for the S series device, we have some modules that can support the EVPN level 3 and VXLAN, but this device it can support the EVPN level 2, level 3, and VXLAN. But if you want to use it on the for example for the IPv6, SRv6 and SMPOS, you must need to use the NE device. Just because now only the NE device can support these features, and if you want to use EVPN to support for these features, you must use Yes, NE be very expensive, but as I know that this module NE on this 3, yep. But for this device, it is not so expensive. NE Night 0 and module 6. It is not so expensive. You can check it if it is available for you. Okay, now let's continue. And I think if you have any questions about how to set up the lab exam, the lab training, maybe you can send emails to our certification email address, and maybe you can get the suggestions for you. But for now, one thing I can be certain is for our recommendation, the device will be NE 800, 8,000, and it will be this device. And I think it should be the cheapest NE that will be available for you. Okay, now let's continue. And then we need to deploy the OSPF v3, and you'll find that we still need to use IPv4 address to function as a root ID. So you need to design it. And for the OSPF v3, and you will find that when we enable the OSPF v3 on the interface, you need to followed by another additional parameters. It will be the instance, just because you should know that for the OSPF v3 we have multi instance. So by use one link, maybe we can establish more than one OSPF pair, right? And after we finish the OSPF v3, then the things is we need to check the OSPF v3 routing table, and the command is just a little different. You find that swap the OSPF parameter to OSPF v3, and then it is the SIS for IPv6. It is more easier. You'll find that just use this command IPv6 enable topology IPv6, and another command. Then all the SIS command just one has one different thing part. It is this command. But another different is when you try to enable SIS on one interface, the parameter will be different. You need to use SIS IPv6 enable and followed with the process number. It will be different. And now what we have done is we have already finished the OSPF v3 between PE1 and PE2, and we have already finished the IPv6 SIS between those three devices. What will be next? The next it should be we need to light PE1 and PE3 then router that generated by each other. So we need to do the route imported on PE2 and PE4. So you will find that it is not it is very easy. Just we need to add the OSPF v3 wheel, and we need to add the SIS wheels to do the route import. But just notice maybe the command will be a little different in the OSPF and SIS wheels. You will find that for SIS, the IPv6 route, and you should know that for SIS, just one process can support the IPv4 and VP6. So when you try to import routers, you need to tell the SIS process which route you want to import. So you need to use this parameter IPv6, and then use the imported router to import the OSPF routers into the SIS for IPv6 topologies. Okay, now the next is what? The next it should be we need to exchange routers between P1 and PE2, and we said that before. We use the loopbacks zeros IP address, IPv6 address to function as the source address for the BGP peer. So we need to make they can reach each other's loopback zeros interface. So you will find that now we will use this address, the IPv6 root static. We need to use this command, and so they can communication with each other's loopback zero interface properly. And then we need to use the MP BGP protocol just to establish the peer relationship by using IPv6 address. You will find that we need to configure the peer, and the peer's address is IPv6, and we need to configure the BGP method hop command, and then we need to enable the IPv6 address family. Okay, and then we need to network the P1's loopback 1. You should notice that it is loopback 1. This interface just to let it function as a survey subnet. And then the things we need to do is we need to configure the IBGP peer relationship between the PE1 and PE3, just to let the router will be delivered to PE2 and PE4, and maybe you can use this command. Wait a moment, and then the things is we need to configure the MPBGP IBGP peer relationship between the PE1 and PE3s, right? And we use the P2 to function as a RR. And the next step is we need to import routers just to do this. And just to light, we import routers from the SS to BGP just to light the P1 can render the routers that are generated by P1 and P3. And another thing is now P1 and P3 don't have the routers that are generated by the P1. So how to do that? We can just to do these things. We can import a router from BGP to SS. So now for the P1, it has a router that is generated from the PE1 and PE3, just because in P2 we import the SS router into the BGP, and then for the PE1 and PE3, it has a router that is generated by the PE1, just because in the P2 device we import the BGP router into the SS, and then you should know that on PE2 on the PE4 we import SS router to OSPF. So by this process, we let the P1, PE1, PE3, they all have the routers that to each others, so they can communicate with each others. That is what we do in this experiment. You will find that this experiment is not difficulties. We just try to show you how to how to configure different IGP protocols or BGP protocols in the IPv6 version. That is the aim of this experiment. So now we have already finished our UAP experiment and IPv6 routing technology experiment, and maybe we will have the demonstration in the next experiment. maybe you will find that in the VXLAN lab, we have 3 sub experiment. The first one is static VXLAN tunnel, and then it is a centralized VXLAN gateway, and then it is a distributed VXLAN gateways. For the for the first one and the second one, it is not too difficulties. But for the last one, I think it will be much difficulties for you to understanding it. So I think you must to see the demonstrations to see how the VXLAN work with the European protocols. Okay, now we have already finished this part. Maybe we can take a rest for 10 minutes. If you have any questions, you can type it for everyone. The next one is the IPv6 transition technologies. It will introduce how to revolution your network from the IPv4 to IP6. And I think maybe in this slide, it will introduce a lot of solutions and the technologies that maybe the solution will use to you. And maybe not every technologies and solutions is the common technologies. Maybe it is just a private technologies of Huawei's, so you can try to learn it.